When I'm working with complex fractions, the first thing I want to do is identify where the main fraction bar is. So I will go ahead and highlight those so that I can see what I'm doing here. Let's do that on this next one. Complex fraction is a fraction over a fraction, so you have to determine where that original fraction bar is. Usually they'll make it longer so you can see it. Now I'm going to put my binomials in parentheses. These do take a little bit of work. I'm going to make a fraction bar, and everything that's on the outside is going to go on the top. So I have a family of y minus 4, family of y plus 2. Everything on the inside, oops, I forgot to put that binomial in parentheses, goes on the bottom. So I have a 2 and a family of y squared minus 16. Now I need to factor if possible. So I'm going to take each one of these families and see if I can factor them out. Y minus 4 does not factor. Y plus 2 does not. I have a 2. Okay, y squared minus 16, that's a difference of 2 squares. So when you have a difference of 2 squares, you split up the first term. Your signs are opposite, and you take the square root of the last term. The square root of 16 is 4. Now any families that are on the top that are the exact same as the ones on the bottom, they cancel out. So y minus 4 cancels with y minus 4. Y plus 2 cannot cancel with y plus 4 because it's not the same thing. And you can't cancel the 2's because one's in a family and one's not. You don't want to split apart the families. So whatever's left over is my final answer. Y plus 2 over 2 times y plus 4. You do not multiply anything back out. You leave the parentheses in your answer. Okay, so let me put parentheses around my binomials. Make my fraction bar. Outside goes on the top. So I have v squared plus 8v plus 15 and a positive 4v squared. Inside goes on the bottom, so I have a family of v plus 4 and a family of v plus 5. Okay, now on the top, look at this. I have a total of 5v squareds on the top. So let's go ahead and put those like terms together. Everything else stays like it is. Now I'm going to come out here and take that trinomial on the numerator and factor it. So 5v squared plus 8v plus 15. You take the first and the last and multiply them. 5 times 15 equals 75. And we want the factors of 75 that when you add them equal 8. So 75 divided by 1 is 75. 2 doesn't work. 75 divided by 3 is 25. 75 divided by 4 doesn't work. 75 divided by 5 is 15. 6 doesn't work. 7 doesn't work. 8 doesn't work. 9 doesn't work. 10 doesn't work. 11 doesn't work. 12 doesn't work. 13 and 14 don't work. And 15 we've already got. Okay, we want to see which combinations add up to 8. There are none. If there are none, that means this original one cannot be factored. So this is actually the final answer. So you do have to check any trinomials to see if they can be factored. If they can't, leave them alone. Okay, so binomial outside on the top. So I've got x, I'm sorry, I said top. X squared plus 6x plus 5, and then I have a positive 4. Inside on the bottom, 24x and a family of x plus 5. Okay, my like terms on the top, 5 plus 4. So I can rewrite that to say x squared plus 6x plus 9, because 5 plus 4 is 9. And I've got 24x times x plus 5. Now, the trinomial on the top, it looks like it might be perfect squares because the square root of 9 is 3. So let's test that. If it is a perfect square trinomial, we make this pattern and you've got an x and the sign after it, and then the square root of the last term is 9. So square root of 9 is 3. Then you multiply everything together. 2 times 3 times x is 6x. That's what we have in here. So that means yes, this is a perfect square trinomial, which means it's x plus 3 twice. And on the bottom, we have a 24x and an x plus 5. Now, nothing can cancel. We don't have any families on the top that are the same on the bottom. And the numbers and variables don't simplify. So that's actually the final answer there.